Since Sputnik first streaked around the Earth in 1957, man-made satellites have become the foundation for modern communication, Earth observation, and other critical military, civilian, and commercial functions. As satellites become more numerous every year, a threat grows with them. Man-made space debris, including spent rocket stages, defunct satellites, and fragments as small as flecks of paint. It is estimated that more than 500,000 pieces of debris currently hurtle around the Earth between 7,000 and 17,000 miles per hour, depending on their orbits. At those speeds, even the smallest impacts can damage or destroy satellites, increasing the amount of orbital flotsam and creating minefields in space that can remain unpassable for centuries. With the risk of space collisions accelerating, tracking debris is essential for warning of impending collisions. Some satellites can use that time to make small adjustments to their orbit or take other actions to protect themselves, but these capabilities are limited and some satellites lack them altogether. Tracking debris is the cornerstone of space situational awareness, not just to protect existing commercial and government satellites, but also to ensure that paths to critical locations in low Earth orbit, geosynchronous orbit, and orbits in between stay clear and safe for future space assets. For these reasons, the U.S. Department of Defense has made space situational awareness a top priority. The historical steward of this responsibility has been the U.S. Air Force, which operates the U.S. Space Surveillance Network, a worldwide network of 29 military radar and optical telescopes charged with observing and cataloging space objects to identify potential near-term collisions with orbital assets. To help the Air Force continue to provide the best space situational awareness possible, the Defense Advanced Research Projects Agency, or DARPA, has developed the Space Surveillance Telescope. From its mountaintop perch at White Sands Missile Range in New Mexico, this revolutionary optical telescope, called SST for short, combines several groundbreaking technologies that are enabling much faster discovery and tracking of previously unseen or hard-to-find small objects. SST has moved space situational awareness from seeing only a few large objects at a time through the equivalent of a drinking straw to a windshield view with 10,000 objects at a time, each as small as a softball. SST can search an area larger than the continental United States in seconds and survey the entire geosynchronous belt within its field of view, 1/4 of the sky, multiple times in one night. SST achieved first light and acquired its first images in February 2011. DARPA and Air Force Space Command completed SST's initial military utility assessment in 2012. And every year since, the telescope has become a more prolific and powerful tool for tracking small space objects. Air Force Space Command is now poised to take ownership of SST and has announced plans to operate it in Australia jointly with the Australian government. Australia offers a uniquely beneficial vantage point for operational testing and demonstration of SST's capabilities. From its new home, SST will provide key space situational awareness information from the Southern Hemisphere, an area of the geosynchronous belt that is currently sparsely observed, to the Space Surveillance Network. SST will also continue to provide NASA and the scientific community with surveillance data on transient events such as supernovas, as well as potentially hazardous near-Earth asteroids. In preparation for SST's move to Australia, DARPA has upgraded the telescope's camera, faint object detection algorithms, and search speed to make it even more effective. SST's numerous technological breakthroughs and their potential to help augment space situational awareness capabilities both in the United States and Australia represent another success in DARPA's pursuit of its singular and enduring mission: to make pivotal investments in breakthrough technologies for national security.